This is the second example. Draw the SFD BMD of the figure shown here. Okay. We are going to follow the same steps we have previously followed. First, we are going to calculate the total force acting on the beam is equal to 3 kilonewton plus 2 into 1.25. We can write as 2 into 1.25, which is nothing but 3 plus 2.5, which gives the answer 5.5 kilonewton. This is the total force acting on the beam. Therefore, reaction force nothing but Ra is equal to 5.5 kilonewton, because the force acting on the beam is carried by this member Ra, which is equal to 5.5 kilonewton. Third step is calculation of shear force diagram. Okay, shear force at B right is equal to B right 0. Shear force at B left is equal to, this is also 0. Shear force at C right is equal to, here 2 kilonewton per meter udal is acting at a distance of 0.25. We can take that 2 into 0.25. It is acting downward, therefore the sign convention is positive. We can write it as like this, and 2 into 0.25 is equal to 0.5 is equal to 0.5. Okay, after that C left, okay, C left is equal to 0.5 plus this 3 kilonewton force, which gives the value of 3.5. okay, similarly D right, in D right all this udal is seen. Okay, we can write it as 3 kilonewton plus 2 into 1.25, which gives the answer as 2 into 1.25 nothing but 2.5, which gives the 5.5 kilonewton. Okay, D right, and after that D left is equal to same, we can write the value. Okay, after that A right is equal to same values are getting, we can write it as 5.5 kilonewton. After that A left is equal to the 5.5 force, which is neglected by this 5.5 force, that's why value of A left is 0. This is the calculation of shear force diagram. Check the values 0.5, 3.5, 5.5, 5.5, all are positive. Take these lines. Okay, after that all are positive. Baseline is here. Okay, this 0, this 0. Okay, B right, B left both are 0. C right is 0.5 means here. Okay, C left is 3.5 means here. After that D right is 5.5 means 5.5. D left is 5.5. Okay, A right is 5.5. and last is LFD 0. Now we are going to draw the shear force diagram. Here are the vertical forces. Draw this line. Okay, this is vertical force. Draw this line. After that, here is nothing, no force is there. That's why we are going to draw the straight horizontal line. Now here UDL is acting. That's why we are going to draw the straight inclined line. Straight inclined line. Okay, this is the positive shear force diagram. Okay, the next step is calculation of bending moment diagram. Okay, bending moment at point B is equal to 0. Bending moment at point C is equal to, bending moment at point C is nothing but this force into this distance, means 2 into 0.25. This is the value of force which is acting half of this distance. That's why we are going to write 0.25 divided by 2. This is the value of force. Okay, and the sign is negative. Sign is negative. Okay, if we calculate it in calculator, bending moment at point C is 0.0625 minus. Okay, similarly bending moment at point D, bending moment at point D, which is equal to force into perpendicular distance, means 3 into 1 minus 3 into 1 minus this whole UDL, means we can write 2 into 1.25, and which is acting half of this distance, that's why we are going to write this. After calculating the values in calculator, bending moment at point D is minus 4.5625. Okay, and last bending moment at point A is equal to force into perpendicular distance minus 3 into perpendicular distance is 1.25. Okay, minus this whole UDL, means 2 into 1.25, which is acting at the middle of this, means 1.25 divided by 2. But we are taking from point A, we are going to add this distance also in that. Okay, that's why we are going to write as plus 0.25. This is the condition. Okay, if we calculate in calculator, the bending moment at point A is minus 5.9375. Okay, kilonewton meter. Okay, now we are going to draw the bending moment diagram. All values are negative, that's why we are going to draw the baseline near to this. Bending moment at point B 0, E is also 0. Okay, after that bending moment at point C is minus 0.0625. After that at point D, means here the value is minus 4.5625, and at last bending moment at point A is 5.9375. Okay, now we are going to draw the bending moment diagram. Okay, here nothing is there, we can directly connect as straight inclined line. Here UDL is there, that's why we are going to draw the parabolic curve. This is straight inclined line. This is called as negative bending moment. Here, thank you.